Hello guys, we are back with our next lecture. In this lecture, let us go through natural joint and all types of joints in SQL guys. So in our few lectures ago, we have clearly discussed all about these joints in relational algebra, right? So the same concept is in this natural joints in SQL also guys, okay? So that is the reason why most probably I will not be explaining you in detail again. So like example step by step, I will be just showing you the example, okay? Yes. So first of all, what is a natural joint guys? So before understanding natural joint, we should understand Cartesian product, right? So whenever we are working with Cartesian product, here we are going to multiply each and every element with each and every other. So if you perform a Cartesian product in between these two tables, we are going to get these many rows, right? So 1p with everyone, 2q with everyone, 3r with everyone. So we got 9 entries here. But in reality, here both of these are b's, right? Means only both b's equal should come, right? Yes. So if you select only these things, that is nothing but natural joint guys. Got it? Yes. So whenever you are applying for a particular table, so assume that you want to perform Cartesian product and you want to get only these two results. So at that time you should write a condition that the value of b in r1 dot b should be equal to the value of r2 dot b. So basically if both of those values are same, then you print them. So in that way if you write, you will get only these two particular rows. Got it? Yes. So this is the exact thing which is done internally by the natural joint. The symbol for natural joint in relational algebra is this, and when it comes to natural joint in terms of SQL, it will be written as a natural joint, like full form. Got it? Yes. So in SQL, everywhere we write the full forms guys. We never use shortcuts or symbols. Got it? Yes. So to make the life of SQL programmer easier, for this common case, SQL supports an operation called natural joint. The natural joint operation like Cartesian product operation on two relations and produces a relation. Okay. So the best thing I think it will be if we take some examples, right? Yes. So let us take a small example. So let us assume that find the name of all customers with the balance, with account balance. Okay. So with account balance who have an account in the bank. Okay, so whoever is having an account, we are checking their account balance, right? Yes. So here, what are we trying to print? We are trying to print the customer name as well as the balance, right? Yes. From which table we can use? We can use the amount table or account table. I think this table should be account table. Okay. So account table with a depositor. Okay, so from these two tables we are trying to get the data, but there is a small thing here, but this customer name is not there in this table. So that is the reason why we are trying to combine them. So if we are combining them, what is the thing here guys? So if we want to combine them, we should check the condition with respect to this account number, right? Because account number is a common attribute in between them and it is 100% unique. So that is the reason why we are going to perform equality operation in between these two. So by this observation, what is this guys? So here we are combining two tables and we are writing our own condition. So this is nothing but Cartesian product guys. So there is no symbol or no word for Cartesian product. Just if you write from two table names, it is internally going to perform Cartesian product and it will apply where condition and it will get the data. Got it? Yes. Okay. Similarly, if you want to do the same thing with respect to Cartesian product, okay, so sorry, with respect to natural joint, so just to write natural joint in between. So there is no need of this condition also, just to write in between natural joint. That's it. Okay. Yes. So that's what it is written in the next statement. Okay. Yes. So in the same way, you can apply for multiple tables also and everything. Okay. Yes. So now I think everyone got a clear idea with respect to this natural joint, right? So write an SQL query to find the name of customers who have an account in branch situated in Delhi. So select a customer name from a depositor, natural joint with the joint branch. So basically here they are trying to map customer names with the branch names, right? Yes. So now we need to combine depositor with account. So that's what it is being done here, right? So depositor, natural joint with branches, where branch is city. So they are checking whether it is city, which city it belongs to, and based on that we are going to decide. Got it? Yes. So even for 3 tables, 4 tables also you can perform guys. So in this way, R1 natural joint, R2 natural joint, R3 natural joint, in that way. Got it? Yes. Okay. So now I hope everyone got idea about natural joint, right? Yes. So now let us recall about inner joint and outer joint, left outer joint, right inner, right outer joint, full outer joint, right? Yes. So when it comes to these symbols, so this is the symbol for left outer joint, right? So on the left side you will keep open, and when it comes to right outer joint, so it will be open on the right side. So when you talk about full outer joint, it will be open on both the sides. So the only concept with respect to these three joints is, so when we are talking about left outer joint, you are going to give more preference to the left side elements. So these left side elements are indirectly mandatory, guys. You can assume in that way, okay? Yes. So those are mandatory. So basically you will first write 1P, 2Q, 3R. So I wrote them. After that I will try to connect these values with these values. So I connected QX. So I can connect this Q here. So I will write X here. Similarly R here. So RR I will write Y here. Got it? Yes, but there is no particular connection for P, so I will write null there. So whatever are empty slots, you will just write null there, guys. That's it. Okay. Yes. Similarly, what about right outer joint? So here you will give preference to right side. So here you will get null on the left side. Okay. Similarly, what is full outer joint? So you will mandatorily write all of them, and you will write null wherever it is required. Got it? Yes. Or in simple words, union of these two is nothing but full outer joint. Got it? Yes. Okay, so now I hope everyone got a clear idea on this. So if you are still having any doubt with respect to this natural joints, I request you to watch relational algebra natural joints, guys, because I have solved this particular paper on that lecture only. Okay, yes, and I don't want to repeat and bore the people who have watched that lecture, right? Yes, so that is the reason why I am skipping the explanation for this particular thing. I have explained you overall. Okay, yes. So now I hope everyone got a clear idea with respect to this outer joint and all those things, right? Yes. So in the next lecture, we'll be discussing some aggregate functions, and after aggregate functions, we'll be discussing about ordering class and like operators. Okay. Yes. So let us meet in the next lecture and discuss about them. Okay. Yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share, and subscribe for more awesome videos like this. Thank you.